All right, so we're asked to give examples of functions that functions f and g such that they meet these criteria, right? So we've been told that the limit of these two functions, g of x and f of x, as they approach zero is the same, right? But the value of these functions are not the same at x equals zero, right? So you just need to add at x equals zero. Okay, so how do we reason about this, and what might these two functions look like? Okay, so I mean, you could come up with any number of examples, but so first of all, we're just concerned with the point x equals zero. So let's say this is x, right? And this is f of x up on the f of x and g of x, okay? F of x and g of x on this vertical axis, right? So we are interested in finding functions that fit this criteria. So one example would be, so let's let f of x equals x squared plus 2, okay? And this would look something like this. So this would be, let this be x, this would be 2. So x squared plus 2 is just the y equals x squared function, okay, but just shifted up by 2, okay? I'm just gonna erase this, okay, and then we can have, well, let me just make this a little bit bigger so it's easy to see. Okay, so now, so this is x equals 0, okay, so this is 0, right? And we can define another function, right, the g of x. So let's say g of x is the inverted version of this. Let's say minus x squared plus 2, okay? But if we plot this number, sorry, if we plot this function, we get something like this. Oops, that's terrible. We get something like that, right? Just move that around. But the problem with this is, at x equals 0, both of these functions have the same value, right? At x equals 0, both of these x terms become 0, and both of these functions have a value of 2. But we're told that these two functions cannot have a value that is the same at x equals 0. So what we can do is we can simply say this. We can say, actually, we're going to define this g of x function to be like this, piecewise. So we can say minus x squared plus 2, and we're gonna say at, this is x squared plus 2 for all x, for x not equal to 0, and then we can say the function is something like, it's 3 when x equals 0. So then this function would change to have a circle here, like an empty circle, so it's not defined there, and then it'll have 3 here and a point here at 3. Okay, so now these two functions meet our criteria, right? Both of these functions, as we get closer and closer to 0, have the limit of 2, right? You can see that, so if we move towards 0 from this side, towards 0 from this side for g of x, we can see as we get closer and closer to 0 from the left, we get closer and closer to 0. Pardon me, 2. And as we get closer and closer from the right, we can see that we get closer and closer to 2. Similarly, for the function f of x, we can see as we get closer and closer to 0 from the left, we get closer and closer to 2, and closer to 2 from the right. But at the point x equals 0, these two functions have different values, right? At x equals 0, g of x is 3, and at x equals 0, f of x is 2. So therefore, it satisfies both of these conditions. So we can say this is satisfied and this is satisfied, and this would be a solution to our question. Okay.